This is Review A, numbers 21 through 30. On number 21, we're looking for an equation that has a horizontal asymptote of y equals 4. The answer here is going to be D. Remember that when you're looking for horizontal asymptotes, you compare the power of x on top, or the highest power of x on top, to the highest power on bottom. Well, in answer choice D, we have squared over squared. So they're same over same, which means that you put the coefficient over the coefficient. So we have 16 divided by 4, which is 4. In answer choice E, you had same over same, but it was 4 over -1, which would be a -4, so be careful there. On 22, let f be the function defined by f of x. What is the absolute minimum value of the function? Now, one thing to remember here is that when it asks you for the minimum value, that's going to be the y coordinate. Okay, when we find the first derivative and set it equal to 0, we're going to get the x coordinate, but then we have to plug it back into the original equation to get the y value. That's going to be the minimum. Okay, so f prime will be the bottom times the derivative of the top. Okay, so the bottom is x. The derivative of the top is -2 times 1 over x minus, the bottom times the derivative of the top minus the top, which is -2 ln x, times the derivative of the bottom, which is just 1. So now here the x's cancel, and we have -2 plus 2 ln x. And we're going to set that equal to 0. Every time you're looking for minimums and maximums, you want to set the derivative equal to 0. Let's add 2 to both sides. Divide by 2, so we have 1 is equal to ln x. Now rewrite this in exponential form to solve for x. E to the 1 equals x, so x is e. And again, we have to plug that back into the original equation to find the y coordinate. So we have -2 ln e over e. Remember, ln e is 1, so it's -2 over e. Okay, on 23, it says that P of t is the population at time t. Which of the following differential equations describes linear growth in the size of the population? So what we're looking for is the slope linear. Okay, so we need a linear slope. Each of these is slope, but we want it to be a line. Okay, so first of all, t has to be the independent variable. All right, so on the bottom we have all the t's, but that means our equation needs to be in terms of t also. Okay, so the change in the population with respect to the time has to be linear. This one is linear. This one is also linear, but it's not growth. 100 is a constant, there's no growth there. Okay, so the slope is linear. The change is linear. Okay, let's look at 24. Let g be the function given by g of x equals x cubed e to the 2kx, where k is a constant. For what value of k does g have a critical point at x equals 1/2? Okay, so critical points, you're going to be looking at the derivative and setting it equal to 0. Okay, so we've got g prime of x is equal to the first times the derivative of the second. When you're differentiating e to the u, you always keep it and multiply by the derivative of the exponent, so that'd be 2k. Okay, so the first times the derivative of the second plus the second times the derivative of the first. Now I see that we have a couple of common factors here. Let's take them out. So x squared e to the 2kx is a common factor between each term. Here we'd be left with x and plus 3. Oh, I forgot my 2 here. 2x plus 3. Okay, now we set that equal to 0. This factor is never going to be 0. E to the 2kx is always going to be positive. It will never equal 0. So we can really just work with 2x plus 3. Subtract 3, divide by 2. X is -3 over 2. Okay, let's look at number 25. Which of the following is the solution to the differential equation with the initial condition y of pi over 2 equals 1? Okay, so you have to separate your variables. So you have dy equals 3 cosine x dx, and then integrate both sides. So when I integrate dy, I get y. When I integrate 3 cosine x, I get 3 times sine x plus c. Now I need to plug in x and y. Okay, so 1 is equal to 3 sine pi over 2 plus c. So the sine of pi over 2 is 1. So I have 1 equals 3 times 1 plus c. If I subtract 3 from both sides, c is negative 2. Okay, so now plug this back in up here, and I've got y is equal to 3 sine x minus 2, which is answer choice A. Okay, number 26, let g be a function with first derivative given by g prime is equal to the integral from 0 to x of e to the negative t cubed dt. Which of the following must be true on the interval 0 to 3? Okay, we see a lot of increasing, decreasing, and concavity. So when I see this, I always think fundamental theorem. Let's differentiate both sides so that I can get rid of the integral symbol. So the second derivative is going to be equal to e to the negative x cubed. Okay, the second derivative is e to a power, which is always going to be positive. No matter what I plug in for x, I'm always going to get a positive value here. So I know that the second derivative is positive, which means the original function is concave up. So I can go ahead and get rid of a couple of these. Okay, now I need to decide if g prime is positive or negative. So when I think about this, g prime is this integral here. I know that the parent function is e to the x. Well, if I make that negative, then I flip it over the y-axis. So it's going to look something like this. Well, it's increasing everywhere, so that means that g is increasing on that interval from 0 to 3. Okay, let's look at 27. If 2x plus y dy dx is equal to x minus 2y, what is the value of the second derivative at 4, 0? Okay, so we have to use a little bit of implicit differentiation here. Get another piece of paper so that I have space to do that. Okay, the first thing I want to do is move this 2x plus y to the other side. We'll make the differentiation easier. So we'll divide by it. Okay, now the second derivative, d2y dx2 is equal to the bottom times the derivative of the top. Now the derivative of 2y is 2 dy dx. Don't forget to put dy dx. Minus the top times the derivative of the bottom. So 2 plus dy dx, again, the derivative of y is just dy dx, all over the bottom, squared. Okay, now I'm going to go ahead and plug in 4 and 0. The other value that I'm going to need to plug in is dy dx. So let's evaluate this at 4, 0 so that I have a numerical value to plug in there. Okay, so 4 minus 0 divided by 8 plus 0 is 1/2. Okay, so I have 2 times 4, which is 8, plus 0, times 1 minus 2 times dy dx, which is 1/2. So 2 times 1/2 is 1. 1 minus 1 is 0. X is 4 here. Minus 2 times 0 is 0. 2 plus 1/2 for dy dx. Divided by 2 times 4 is 8. Squared is 64. Okay, so now I have 0 here. And then here I have 2 plus 1/2, which is the same thing as 4 halves plus 1/2, so 5 halves. 5 halves times 4 is 20 halves. 20 halves is 10. Reduce that by a factor of 2, and we have negative 5 over 32, which is t. Okay, on 28, you're given the position function, and it says what is the acceleration at the point where the velocity is first equal to 0. So I need to find where the velocity is equal to 0 first. So we need to differentiate x. So the derivative of cosine is negative sine. The derivative of sine is cosine. Set that equal to 0. Okay, add sine t to the left. Okay, so think about your unit circle. The first place where the x and the y, or rather the y is equal to a negative x, would be in the second quadrant at 3 pi over 4, where you have negative root 2 over 2, root 2 over 2. Okay, the y value is root 2 over 2. The x value is a negative version of root 2 over 2. So that's at 3 pi over 4. Now the question says to find the acceleration at that time. So we need to differentiate the velocity here. So the derivative of negative sine is negative cosine. The derivative of cosine is negative sine, so two negatives make a positive. Okay, and we need to plug in 3 pi over 4. Okay, so the cosine of 3 pi over 4 is negative root 2 over 2. So negative root 2 over 2 is a positive root 2 over 2. The sine of 3 pi over 4 is root 2 over 2. So I have 2 root 2 over 2, which is just root 2. Okay, and that answer is E. Okay, on 29, it says the graph of the function g is shown in the figure above. For which of the following values of x is g prime negative and decreasing? Okay, and again, g prime is negative and decreasing. So if this is g, I need to look for a negative slope, and it needs to be concave down. Okay, this is the slope of the slope, so concave down. Okay, so it's decreasing and concave down. That occurs at point P. Okay. Number 30, we're given a closed interval. We've got f of 0 is 5 and f of 2 is 15. Which of the following is guaranteed by the intermediate value theorem? Okay, the intermediate value theorem, I've attached a page to your review here so you can kind of look over it again. But the answer is going to be f of x equals 11 has at least one solution in the open interval 0 to 2. So the intermediate value theorem says that as long as this function is continuous, then the y will take on every value between 5 and 15. Okay, so 11 is in between 5 and 15. So f of x equals 11 has at least one solution. There's at least one x value where the y is 11 between 0 and 2.